Given question, draw shear force diagram and bending moment diagram. To draw shear force diagram and bending moment diagram, first step is to draw the free body diagram. If we observe this question, then at point A, roller support is given. We will show the reaction at point A in vertically upward direction, and this is known as RA. Now we will move to the next, uniformly distributed load. So it is 1 kilonewton magnitude for a distance of 1 meter, but the total span is given 2 meter. So how to calculate the total load? So here is the question mark. So if we cross multiply 2 multiplied by 1 divided by 1, that is equal to 2 kilonewton load, and it is acting at the center of this span AB. So we will select the center point and we will show here 2 kilonewton load in vertically downward direction. Now we will move to the point C. At point C, 4 kilonewton load is applied at a distance of 0.5 meter. So we will convert this load into couple. So how to convert it? So we know that when the loads of equal magnitude but opposite in direction. So I will show here 4 kilonewton load in downward direction. So I will provide at a distance of 0.5 meter. So here is the 0.5 meter distance. So this is the point C. So at point C, we will apply the same magnitude load but opposite in direction. So here is the formation of couple when the two loads equal in magnitude but opposite in direction are kept at one particular distance. So how to find out the value of this couple? So it is multiplication of this load multiplied by distance, that is 4 multiplied by 0.5, that is 2 kilonewton meter, because its unit is kilonewton and meter. So this is the couple of 2 kilonewton meter, but here we have added extra load 4 kilonewton. So if I add at point C, so this is the load added 4 kilonewton for the formation of couple. So to balance this load, we will add here one load which is opposite in direction at point C. So I will add here same magnitude load, that is 4 kilonewton, and its value is 4 kilo. So if we observe this, then this 4 kilonewton and this 4 kilonewton is getting cancelled, but this 4 kilonewton is used here for the formation of couple. Now how to find out the direction of the couple? So if we observe, if I move the compass in the direction of these two arrows, so if I move the compass here and here, so here is the clockwise direction. So at point C, I will show here the couple that is in clockwise direction, and its value is 2 kilonewton meter. Now what about that extra point load? So we have to show this at point C, that is equal to 4 kilonewton in downward direction. Now we will move to the point D. At point D, hinge support is given. So for this hinge support, we have to show vertical component as well as horizontal component. So I will show vertical component because support is given, that's why direction is in the upward direction. So it is known as RD. Now we don't know the direction of horizontal component. Now we will move to the point E. Now at point E, inclined force is given, that is 3 kilonewton acting at 45 degree with the horizontal. So we will resolve this force into two components. One is vertical and second is horizontal. So what is the value? So this horizontal component is nearby to angle 45 degree. So its value is 3 cos 45. And here is 3 sin 45. Now if we observe, direction of horizontal component is towards left hand side. So at point D, to balance this horizontal force, we will apply the direction of force in the opposite direction. So here is the direction of the horizontal component at point D. To find out unknown values at the reaction at point A and D, we will consider this system is in equilibrium. So we can say that summation of all vertical forces is equal to 0. So I will write here summation of all vertical forces is equal to 0. Now if we observe this RA and RD is in vertically upward direction. So we will write here therefore RA plus RD is equal to this 2 plus 4 plus 3 sin 45, that is equal to 2.1. So we have to calculate this and we will get the equation number 1. Now we will write the summation of all horizontal forces is equal to 0. Summation of FH is equal to 0. So this is the horizontal component at point D. So we will say that this its notation is DH and here the notation is DV. So I will write here instead of RD, this notation is DV, that is the vertical component at point D. Now summation of all horizontal components. So here DH and 3 cos 45 are in opposite direction. So we can say that DH is equal to 3 cos 45 and which is equal to 2.1. When system is in equilibrium, then summation of moment of all the forces about any point is equal to 0. In this diagram, the reaction at point A and D are unknown. So we will select any one point. So we will take summation of moments of all the forces about point D is equal to 0. Now we will consider sign convention. When the moment is in clockwise direction, use positive sign, and for anti-clockwise direction use negative sign. Now for this direction we will first consider the reaction at point A. Now if I move the compass about point D in the direction of RA, then here is the clockwise direction. So we will use positive sign. Therefore plus RA multiplied by distance in between A and D, 6. Now if I move the compass in the direction of 2, then it is anti-clockwise. So minus 2 multiplied by distance. So it is center point of AB. So this distance is 1 plus 2 plus 2, that is 5. Then here is 4 kilonewton. So again it is in anti-clockwise direction. So minus 4 multiplied by 2. Now here the couple is given and this couple is in anti-clockwise direction. So for the anti-clockwise direction consider sign minus 2. Now we will move to the next. Now if we observe DV and DH are acting at point D. So there is perpendicular distance is equal to 0. Now we will move to the point E. Now if I move the compass in the direction of this 3 sin 45, then it is in clockwise direction. So I will use plus 3 sin 45, I will directly take 2.1 multiplied by 1. And this 3 sin cos 45 is passing through the point D. So perpendicular distance is equal to 0. So we are not going to consider this component. So which is equal to 0. Now if we observe, there is only one unknown term, that is RA. So when we calculate or when we solve this, we will get the answer of RA. Next step is to calculate shear force at the different point. It is the summation of forces either on the right hand side or on the left hand side of the selected point. In this question, we will consider the summation of forces which are on the right hand side. We are going to use this sign convention. So if on right hand side, if the direction of force is in downward direction, use positive sign, and for the upward direction use negative sign. And we have to mention these sign conventions in the answer sheet. Now we will first consider the shear force at point E. Now if we observe at the point E, there is the point load. Now when there is the point load, we will consider right hand side and left hand side. I will select the immediate right hand side point and immediate left hand side point. So I will write here right, left. So if I select right hand side point, then on the right hand side there is no any force, so its value is 0. If I select the left hand side point, then on its right hand side there is the force which is in downward direction and its value is 2.1. So I will write here plus 2.1 kilonewton. Now we will move to the next, shear force at point D. So at point D also there is point load. So again I will select the right hand side and left hand side. So here is right hand side, and so these are nearer to the point D. So on right hand side there is only one force, so we will write its value. So it is in downward, it is equal to plus 2.1 kilonewton. And on left hand side, if I select left hand side, then there are two forces. So here is plus 2.1 minus 5. Plus 2.1 minus 5. So its value is minus 3 kilonewton. Now we will move to the shear force at point C. So at point C also there is the point load. So I will write here shear force at point C. So again we will use right and left side. So here is right and left. So at point C, on right hand side there are 2 forces. So plus 2 minus 5, that is minus 3 kilonewton. And if I select left hand side point, then there are total 3 forces. So here is plus 2 plus 4, plus 2 plus 4 minus 5. So it is 6 minus 5, that is 1 kilonewton. Now we will move to the shear force at point B. So if we observe at point B there is no any point load. So I will select here SF at point B. So on right hand side of B there are 1, 2, 3 forces. So it is plus 2 plus 4 minus 5, that is equal to plus 1 kilonewton. At point A, point load is acting. So we will consider the right hand side point and left hand side point of this point A. On the right hand side point there are the forces. We will take plus 2 plus 4 plus 2.1 minus 5, which is equal to 3 kilonewton. And if I take the left hand side point, then we will take plus 2 plus 4 plus 2.1 minus 5 minus 3, and it is equal to 0. So we will write here the number 0. Now with the help of these values we will draw the shear force diagram. So we have to first take the baseline. Now on this baseline we will plot the positive values in upward direction and negative values in downward direction. Now if we observe at point E there are two values which are, because this right and left side point are nearer to the point E. So we will plot these values on the same line. So it is 0 and plus 2.1. So here is 0 on the baseline and I will take here plus 2.1, that is in the upward direction. Then at point D it is plus 2.1 and minus 3. So on the same line D we will plot here plus 2.1 and minus 3. So I will plot here this point. So it is negative sign, so we have to plot this number in the downward direction. Then at point C it is minus 3 and plus 1. So on the same line I will plot here minus 3 and plus 1. Then at point B it is plus 1. So I will plot here the plus 1. Then at point A it is plus 3 and 0. So I will plot here plus 3 and next point is 0. Now we will connect all these numbers from right hand side to the left hand side. So first right hand side is with E with right hand side, that is 0, and that after that it is plus 2.1. So I will connect this. Then we have to connect the right hand side point at point D, that is plus 2.1 and then minus 3. So here we will connect plus 2.1, then it is 3, then here 3 to 3. Then we have to connect 3 and 1 and then 1 to 1. Now if we observe this span BC, CD and DE, all these spans are with point load. So whenever point load is given, then the shear force is constant. That means we have to show the constant line for that span. Now if we move to the span AB, then there is uniformly distributed load. So shear force will vary linearly. So we have to connect this 1 and 3 values with linear line. So I will show this, and then last value is 0. So this is the shear force diagram. Next step is to calculate bending moment at different points. So it is the summation of moment of all the forces either on the right hand side or on the left hand side. We will take the summation of moment of all the forces which are on the right hand side. So if the moment are in anti-clockwise direction, use positive sign, and if the moments are in clockwise direction, use negative sign. First we will select the point E. On right hand side there is no any force, so moment is equal to 0. Then if we select the point D, then on right hand side there is the force in downward direction. So if I move the compass about point D in the downward direction, then there is the clockwise direction. So we will use minus 2.1 multiplied by this distance 1, which is equal to minus 2 kilonewton meter. Now bending moment at point C. Now if we observe at point C, couple is acting. So we will select here the 2 points right and left. Right and left. So if I take immediate right hand side point, then at the right hand side point we have to take these two loads, that is 2.1 multiplied by this distance. 2.1 multiplied by this distance is 3, and if I move the compass, then there is clockwise direction, so with minus 2 sign. Then again for this dV there is the anti-clockwise direction, so use plus sign, 5 multiplied by this distance 2. Now we will consider the left hand side point. So on the left hand side point, if we observe, there are 1, 2, 3 point loads and this couple also. So we will calculate this. So when we calculate for right hand side point, then it is 10 minus 6, that is equal to plus 4 kilonewton meter, and on left hand side point we will calculate minus 2.1 multiplied by this distance 3, then it is plus 5 multiplied by this distance 2, then here is 4, so which is acting or which is passing through this point. So there is perpendicular distance is equal to 0, but this couple we will consider which is in anti-clockwise direction, so we will use positive sign, that is plus 2. So when we solve this, it is minus 6 plus 10 plus 2, and which is equal to, here is 4 plus 2 plus 6 kilonewton meter. So this is the value. So we have to plot these two values on the same line passing through the point C. Now we will move to the point B, bending moment at point B. So again select is 5, minus 2.1 multiplied by 5. Then here is 5 multiplied by 2 plus 2 4. So it is plus 5 multiplied by 4. Then this is the point load. So it is also in clockwise direction. So minus 4 multiplied by 2, and this is in anti-clockwise direction plus 2. So when we calculate this, then minus 10 plus 20 minus 8 plus 2. So here is minus 10 minus 8 minus 18 plus 20 plus 2. So here is plus 2, that is equal to plus 4 kilonewton meter. So this is the bending moment at point B. Now we will move to the bending moment at point A. So again let 3 sin 45, that is 2.1 multiplied by this total distance 7. So there is clockwise direction, so minus 2.1 multiplied by 7. Then here plus 5 multiplied by this distance 6. Then here plus 4 multiplied by this distance 4. Sorry, here is clockwise direction, so minus 4 multiplied by 4. then this couple is in anti-clockwise direction, so plus 2, and this 2 kilonewton is in clockwise direction, so minus 2 multiplied by 1. So this distance is 1, so we have to calculate this. Now we will draw bending moment diagram. We will draw one baseline. We will plot positive points in the upward direction and negative points in the downward direction. So first is bending moment at point E is equal to 0. So we will plot this number on the baseline. Then second is bending moment at point D. It is minus 2. So we have to show this in the downward direction. So we will show magnitude only. Now if we observe in between the span DE there is only point load. So bending moment will vary linearly. So we have to connect this 0 and 2 with linear line. Now bending moment at point C. So there is right side and left side point. So right side point is plus 4 and left side point is plus 6. Now if we observe, we are moving from right towards left. So there is first point E, then second point D, then next point we have to connect with right side of C. So right side of C is plus 4. So we will connect 2 and 4 with linear line, because in between this span CD there are point load only. Now in between B and C, if we observe, there is only point load. Now on the same line there is plus 4 and plus 6. So we have to plot these two numbers on the same line and we will connect here. And then bending moment at point B, it is plus 4. So if we observe, here are also point load. So we will connect this 6 and 4 with linear line. And at point A, value is 0. Now if we observe in the span AB, there is uniformly distributed load. So bending moment will vary with parabolic curve. So we have to show here the parabolic curve to connect these points.